Thank you. At this time, we'll take questions from the judges, and then anybody else will open it for the floor.
You brought back memories because I lived close by, and Baracoa is surrounded by mountains, and the rural areas in Cuba were basically from rivers, as you mentioned, but also from groundwater. Although Baracoa being in mountains, that would not have been feasible. But the question I have, not being civil engineer, is how significant is the maintenance of that permeable concrete, and how often you have to do it, what kind of equipment will be required to maintain that ability for potable water?
Certainly. There will need to be regular maintenance, approximately at least at a minimum, two times a year, using that vacuum. It's essentially a vacuum truck that vibrates the ground and sucks up anything that should filter into the surface. That a lot of the material and particulate matter, such as soil or even just dust off of trucks, generally tends to stay on the top half inch of the concrete, of the permeable concrete. So those pores just need to be sucked out and cleaned biannually.
Okay, thank you very much.
I gotta congratulate you. I think this was the purpose of this infrastructure challenge. You took an idea, you took a need, you combined it, you looked at sustainability, and you addressed it very clearly, so I applaud you. A question for you. Did you guys ever consider, because you're looking at the infrastructure replacement, the roadways, from my perspective, did you ever consider using asphalt, flexible concrete, pavement as a potential solution?
Absolutely. So as I was saying earlier, Ryan and I specialize in permeable concrete. So when you saw on those slides, it's just the concrete and the aggregate. We're finding that the main, and he's published a paper on this, so I can say some things. I don't know how much I can say. But we're finding that the cement is the magic ingredient that is cleansing the water through those chemical processes such as absorption. There's papers out there for porous pavements like asphalt and permeable pavers and impervious concrete. And a lot of that has to do with a permeable pavement system, so the aggregates and everything in there. So that being said, we're finding that the permeable concrete is kind of the magic key here. We did consider permeable pavers for maybe the historic district. Our understanding is that they might have some cobble type pavers in there, so we could do an option where we had permeable pavers on top and then pervious concrete underneath of that to kind of get the water cleansing thing, and then aggregates.
I think that you did a very good job. This system of filtrating water, is very, very important, and it have a lot of creativity. But in the case of the amount of water coming from the sea or from the rivers, has to be, studied much, separately. The amount of water, the rainfall of that area, I was asking who was the one advising you in this respect, because close to that area is the highest rainfall in Cuba. Moa and Toa are rivers that are not there but close to. And if you see any kind of hydrography map, you can see how much rain. So it's about twice or three times the amount of water in Havana. So the extrapolation of Havana, I didn't like it, no, because it is not, usable. The second place is when you list all items that you can filtrate. You mentioned nitrates. Why you mention nitrates, I don't know, because there are not many or big farms in that area. You have to see the basins, you have to see where they are located, and according to that, see that kind of thing. The other thing is, if they have been using fertilizer in more than 20 years, why to mention nitrates? I mean, this is something important, that is collateral. It's not the main, aim of this project, but it completes the project. So I really, these are my two types of questions.
That's a fair concern with the precipitation of Baracoa. We worked to the best of our ability using some of the resources we had. As far as the nitrates, we use that as an ability just to round out how it's effective for several different applications of cleaning. The great thing about the implementation of this is that it's potentially modular. This is the $33 million deployment. It obviously could be deployed at a smaller scale, and it can be built up as the city grows.
Also, I wanted to mention that the flow rate on this pervious concrete is significantly higher than any flow rate that you'll see in a rainstorm. So, for example, let's say the storm event was at above at triple that value. We're talking about the pervious concrete can infiltrate approximately, at a minimum, 3 centimeters per second. So you would have to exceed a significant amount in order to, which obviously we would have to further investigate that, definitely. Thank you.
Well, congratulations, a great idea, and I think that there will be many places in the world to put it. I'm not so sure it will be good in Baracoa or anywhere in Cuba. And the reason my concern is about the costs. When we're talking about an infrastructure that will have to replace complete piping, and you have to dig tunnels, 1 meter diameter pipes, and all the collection items, and all those things will have to go to a water treatment plant, because you're not 100% sure that water is 100% drinkable. And you cannot say, okay, well, it's going to be filtered completely, and people will drink it directly from there. Or you'll have to do some substations to put it there. So I don't think that $23 million is a reasonable number to put. Nevertheless, I think it's a great idea. Just a comment I want to second what Vladimir said. You cannot assume data from another place to Baracoa, neither Miami nor Havana. It doesn't matter whether in the same country or not. You have to be very, very careful. As an engineer, you really have to make sure that you have the right data, because if you have a wrong assumption, you get the wrong conclusion. So that's very important as you go progress in that. Still think it's a great idea.
Again, I want to congratulate you. Water shortage existed in Cuba in the 50s, and it's obviously gotten a lot worse. Has this been done on any coastal cities? Because I love your looking forward, which you addressed here also on the report. What happens when you have a hurricane and you get saltwater infiltration? Obviously, during most of the time, you're concerned with a runoff from the mountains. That's that big storm surges that you have. But how is the salinization handled?
That's the big question as far as pending research we need to understand. A lot of the research, as I said, is coming out of China. I have some of that research. It's in progress of being translated. As far as desalinization and the salinization aspect is, you can mitigate that risk through a number of mechanisms, staying away from kind of the surge whale, a certain amount of distance away from the shore. That's one aspect.
Additionally, there typically needs to be a cleansing period immediately after. For example, we would most likely install some sort of closure system on each of the cisterns or in the system to try and prevent any intrusion into your existing water. And that would be have to stay closed until that water had reached a certain level of salinity, which of course is allowable, but not to the same extent. Additionally, pervious concrete is showing some capacity, when designed appropriately, to remove salt water. So it would prevent such things as like gales or any inward winds, like will bring salt. Well, that may not be sufficient to overcome the ability of the concrete to actually remove that salt from just the rainwater or existing local water system.
Okay. Again, congratulations.
At this time, we still have a couple more minutes, and we'd be more than happy to open it up to the audience if there's any questions from anybody in the room. Can we give the microphone to Mr. Medina?
Porous pavement was used in Germany about 30 years ago. The problem was the structural strength of the porous concrete. So only light vehicles, a heavy truck would crack the porous pavement. And we've gotten better over the years, but that was one issue.
Ryan can speak to this more specifically, but a big part of that is the temperature, the climate.
Essentially carbonation and other things. The fact that the environment is so, doesn't experience the freeze thaw that you'd normally experience in some place like Germany for deterioration of the concrete. Additionally, some of the roads that we're targeting for this implementation would be something like the side roads, not necessarily the main highway, partially because we don't want to destroy any existing infrastructure. We're more interested in improving the surrounding infrastructure. And additionally, you're right, the loading is definitely something we'd have to consider, and the design would have to be very much focused around what is available and what roads do people normally take to take their heavy trucks or semis.
Thank you.
Definitely.
All right, we're going to call it on this presentation. So thank you very much to the team from Missouri.